Hello, I'm Francisco and I'm here to talk about excitatory-inhibitory balance and its importance for stroke recovery. Now, stroke is quite intriguing because we have a focal lesion but with such widespread effects. Some of those effects on functional connectivity can be, for example, a structure-function decorrelation or a loss in modularity. This modularity can be recovered in the months following a stroke, but it's not clear how the cortex can orchestrate the reemergence of such a complex property on a global level. What we do know is that the areas that were previously connected to the lesion experience a great loss in the levels of incoming excitation. And we also know that the cortex has homeostatic mechanisms that compensate for these perturbations and recover excitatory-inhibitory balance. And when we look at the brain of post-stroke patients and also rodent models, we see signatures of these mechanisms, such as increased excitability around the lesioned area. So last year, we published a review where we introduced the hypothesis that excitatory-inhibitory homeostasis can be a relevant driver of stroke recovery. But now it's time to test this hypothesis, and for that we built a large-scale model of the human cortex, where local activity is described through a neural mass model, and more importantly, where we also implemented excitatory-inhibitory homeostasis through plasticity of local inhibition. In this model, we applied simulated lesions and measured activity before the lesion, after, and sometime after that, when local excitatory-inhibitory balance was restored. Let's look at our main results. So first of all, we observed that solely through the recovery of VI balance at the local level, we already observed a large-scale reorganization of cortical connectivity, which you can see on the bottom right corner. Importantly, this reorganization led to the reemergence of the lost properties of functional connectivity, such as modularity. But what happens when we look at the adaptations that are required on a local level to achieve this recovery? First of all, we see familiar sites, such as increased excitability in the areas around the lesion, but we also see some signatures of known side effects of stroke, such as seizures. So in summary, we show that the recovery of locally high balance can lead to the reemergence of global properties of functional connectivity, that the adaptations that are required to achieve this on a local level can explain post-stroke changes in excitability, but they can also lead to an increased propensity to develop certain side effects. So we do believe that excitatory-inhibitory homeostasis is an important driver of stroke recovery, but the story doesn't end here. We discuss all these issues in more detail in our preprint. Feel free to check it. And finally, I have to thank Jakub and Paul, my co-authors, for their support, and also you for your attention. See you next time.